Hello friends, welcome to Let's Talk Biotech. In this video, I am going to discuss about electrophoresis, its principle, factors affecting electrophoresis and types of electrophoresis. So, let's begin with the lecture. What is electrophoresis? Electro means energy of electricity and phoresis means to move across. So what is electrophoresis? Electrophoresis means by using the energy of electricity, a molecule tries to move. It is a technique for separating charged molecules in a mixture under the influence of an applied electric field. Here external electric field is applied so that the charged molecules in a mixtures such as RNA, DNA, proteins are separated. The movement depends on size and charge of the molecules. This we will be discussing on later in this session. Talking about the principle of electrophoresis, according to law of electrostatistics, Coulomb's law, we know that E is equal to F upon Q. E is equal to electric field, F is equal to electric force, Q is equal to charge of the molecule. By rearranging this equation, the electric force will be equal to QE. So, the ion with charge Q in an electric field will experience electric force F is equal to QE. The migration is affected by an electric force, right? So, in the same way, it is opposed by frictional force as well. So, frictional force is equal to Vf, where V stands for velocity of ions, F stands for frictional coefficient. What is frictional coefficient? It is the resistance encountered by the molecule. So, by joining both the equation, for the net movement of charged molecules, it is necessary that the electric force should be equal to the frictional force. Why though? Suppose if electric force is greater than resistant force or frictional force or vice versa, what happens is that the particle movement will depend upon only on electric force. And we know that the particle movement is mainly dependent on the charge of the molecule. So for neglecting that, the electric force should be equal to the frictional force. So by putting the equation, QE is equal to Vf, where V upon E is equal to Q upon F is equal to mu. So what is mu over here? It is the electrophoretic mobility. Electrophoretic mobility means it is the migration of charged particle in electric field. And by rearranging this equation, we can get the equation for velocity of charged molecules as well, which is V is equal to QE upon F. So speed is mainly determined by charge to mass ratio. As the charge of a molecule or particle increases, the speed of the molecule will also increase. And if the mass of the molecule or weight of the molecule increases, the speed will decrease. So separation is mainly based on size, shape and charge. Talking about the electrophoretic system, an electrophoretic system consisting of two electrodes, which is anode, which is a positive electrode, and cathode, which is the negative electrode. By taking an example, by taking DNA as an example, we know that DNA is negative in charge, right? So if you load DNA at the negative side, it will move towards the anode. The same principle goes to every molecules. So on the basis of its charge, we are trying to load at which side? At the correct side. So movement for cation is always towards the cathode and for anion is always towards the anode. Factors affecting electrophoresis. The factors including net charge on the molecule. As we discussed before, as the charge of the molecule increases, the rate of migration also increases. And this factor is mainly dependent on pH of the medium. Right. Suppose if you take an example, proteins. The proteins at low pH, the proteins will acquire positive charge. So it will move towards the cathode. And at high pH the proteins will acquire negative charge, so it will move towards anode. So it is necessary that the pH of the medium should be optimum so that the charge of the molecules will not change. Okay, molecular weight. So talking about the molecular weight, the molecular weight of a molecule or the mass of the molecule should be such that if the mass increases than the pores of the gel, then the movement would be very difficult or movement would be very slow. And if it is smaller in size, then the movement would be very higher. And another reason is that it is mainly dependent on the frictional and electrostatic forces. For example, if the migration is very less for larger molecules, and it is mainly due to the frictional and electrostatic force. Shape is another example. For a compact structure molecule, it is very difficult for the molecule to move. pH of the medium, strength of the electric field, temperature, viscosity of solution, these all are the factors affecting electrophoresis. Types of electrophoresis: there are two types of electrophoresis. One is the moving boundary electrophoresis, and the other one is a zone electrophoresis. As the name suggests, moving boundary means it doesn't require any supporting medium, and zone electrophoresis requires supporting medium such as inert matrix or gel in the case of gel electrophoresis. The examples of moving boundary electrophoresis are capillary electrophoresis, isoelectric focusing, immunoelectrophoresis. And zone electrophoresis examples are gel electrophoresis, paper electrophoresis, and thin layer electrophoresis. So each of these electrophoresis will be discussed in detail in our next session. Thank you so much.